Example 2, consider a parallelepiped OABCDEFG as shown. Prove that the diagonals OF and CE bisect each other. And bisect means cut in half. So looking at our diagram, we have CE and we have OF. So this point of intersection, let's let it be some point P. So we're proving that P bisects CE and also bisects OF. So let vector A be OA. So that's there. Vector C be OC. So there. And vector D be OD. Now let X be the midpoint of OF and Y be the midpoint of CE. So if I look at OX, it is going to be a half of OF, which is going to be a half of, now OF is this vector here. So to get that, I can go OA plus AB plus BF. So OA plus AB plus BF. In regards to the vectors given, OA was A, AB is parallel to OC, so that's going to be C, and BF is parallel to OD, so that's going to be D. Now for OY, we're going to have a half of OC plus OE. That's going to be a half of OC plus OA plus AE. Now, if you need to, draw multiple diagrams so you can see this. Okay, it's very hard to illustrate on a small diagram, but make sure you draw them so you can see where this is coming from. So all I've done is I've replaced the OE with OA plus AE. So that becomes a half, OC is C, OA is A, and my AE is parallel to OD, so that is D. Now, you can see these two are the same thing. So therefore, OX equals OY. So therefore, X has to equal Y, and the diagonals of OF and CE bisect each other. Now the next one, let M be the midpoint of CB and N be the midpoint of DE. Prove that the midpoint of MN is the point where the diagonals OF and CE intersect. Again, draw a diagram if you need to. I'm going to get rid of all of my annotations from the previous part. So CB is here, and you can see that midpoint M. And DE is here, and you can see that midpoint N. So we're trying to prove that the midpoint of MN, so this is MN, so the midpoint of that, say that's there, is where the diagonals OF and CE intersect. So OF and CE. Okay, so OM is going to equal OC plus a half CB. Note OM is here. So OM is your OC plus a half of CB. So here, here. That equals vector C plus a half of vector A. ON is going to be OD plus a half of DE. So ON is here. So that equals OD plus a half of DE. So I can rewrite that as vector D plus a half of vector A. Let Z be the midpoint of MN. So OZ equals a half of OM plus ON, which is a half. Replace the OM, which we just found, as C plus a half A. Replace the ON with what we just found, which is D plus a half A. So see where they're coming from? Bring that together. We have a half bracket A plus C plus D. So therefore, Z equals X, because that's what we found in part A. And where X is the point of intersection of OF and CE, found in part A. So therefore, X is a midpoint of MN. Done. And I forgot to write my QED at the end of part A.